Hi everybody, I just built this wave folder. It's right here, and you can build one too. Watch this video and make it happen. Hi, I'm Juanito and welcome to Modular for the Masses. You can build it too, because you can. Today I'm going to build a Lockhart wave folder, or a Lockhart, it's also called a frequency tripler. It takes an input signal and kind of flips part of it upside down and makes it sound very interesting. It's a very simple circuit. It only has a few parts. The important bits are the transistors, which you have an NPN and a PNP. There's an op amp in there just for an amplifier, and there's a guy shooting a soldering gun, and he's saying draw because I like to draw. Okay, let's get started on this sweet project. Alright, here's what's going on with this circuit. I already went ahead and built the front panel for it. We have an in jack. This is basically a potentiometer serving as a resistor divider between the input signal and ground. So if we turn the potentiometer this way, the full signal from the input will be sent straight to the rest of the circuit. If we turn it this way, it'll just be looking at ground. If you want signal to get through all the time, especially a low level signal, you could put a 1K resistor right there, and then have that be, and that would let a pretty close copy of the input signal come all the way through the circuit when the circuit was turned, when this volume knob was turned all the way down. Right here, the signal goes into into the base of these two transistors. This one's PNP, this one's NPN. There's just 20K resistors between the positive voltage rail and the negative voltage rail. And then there's a inverting amp right here, which increases the signal level by 100. So what's coming in here is pretty quiet. It amplifies it that much to get something useful out of it. And then of course there's that 680 ohm resistor to protect the op amp outputs. It's a good idea to include that on all your outputs. It can be smaller if you want. You can go down to 100 ohms, or even less if you choose, or zero, nothing. But then if you plug your output into something that is high, has a lot of current behind it, you might, and your op amp's trying to put out, for instance, 12 volts positive, and you accidentally plug it into something that's trying to put out 12 volts negative, you might blow the output. Okay. Here's a diagram of our TL072 op amp. That's the one I recommend. It's a little less likely to blow up than some of the other really good dual op amps out there, like the NE5532. Go ahead and use a TL072. They're tough. And this circuit only uses 1/2 of the dual op amp, so the other half should be kind of closed off. Inputs should always be tied to something. Alright, so let's get started. Here's my TL072. What a great little guy. Here's a 100 nanofarads ceramic disc capacitor. Super great. Use these on all your power bypassing needs. I'll go ahead and mark off the components as I put them in. This amp is inverting, which means the plus pin goes to ground. And since I'm going to tie off this other one, I'm going to put both plus pins and connect them straight to ground. Of course, that's pin 3 and pin 5. So I'll bend those together like this. Solder them together. And that is going to be our ground point. There's no other, okay, I'm sorry, there is one other ground point in the circuit, which is the other end of this potentiometer. So we'll just go ahead and not put anything, like I'm not going to need a star ground with this circuit. I'll just connect this to the potentiometer and then connect that to the tab for the front panel to give us the benefit of the front panel being sort of a ground plane, a shield for the rest of our circuit. Let's build this part of the circuit first. I've already put the potentiometer in the front panel. This is a 100K dual potentiometer, so it could be used in a stereo circuit. This is just a mono circuit, so we only need the top potentiometer. When you turn the knob, this is going to be all the way up, and this is going to be all the way down. Think about the wiper moving inside. When I turn it up, the wiper goes there. When I turn it down, the wiper goes there. So this will be ground, and this will connect to the input. Okay, that's the input potentiometer. Connect to the input right there. A long time ago, I bought 2,000 1K resistors, and they're beige, which is fantastic because if I see a beige resistor, I know automatically that it's a 1K. It's kind of cool. I recommend doing that if you can be bothered. Because when you're in a panic and you're building as fast as you can, being able to just grab a 1K resistor to protect an LED or to protect an input or an output of an op amp. That's a great value. I also bought 1,000 1K resistors that have really thick leads. They must be antique because they're just 1/4 watt resistors. And of course these are 5% tolerance. So they're really not, and they're probably carbon resistors. I don't really care about using carbon or low precision resistors because I would never use a resistor like this in a circuit where precision mattered. Alright, that's the input. Be right back. other end of the potentiometer. You know what? I'm actually going to include this 1K resistor from the south end of the potentiometer, the low end, to ground. That way we can test the idea that I had that letting the input go through at the lowest value, a 100-to-1 resistor divider, go to this circuit. And then this 100-to-1 gain might let, if you put a sine wave in here, maybe a sine wave will come out here. Let's check it out. Here's my 1,000 ohm resistors. Alright, let's put it there. In my last video, I think I said my last video was a active mixer. That's actually not true. My last video was a VCA, voltage controlled amplifier. The voltage controlled amplifier is a really useful sort of utilitarian circuit. It can be used to replace this potentiometer, turning this Lockhart wave folder into a voltage controlled Lockhart wave folder. And that is going to be something I very much recommend. A voltage controlled wave folder can give you some amazing dubstep type of sounds. The wobble bass, some of the kind of screaming synth sounds. You can get that out of a wave folder. Ooh, I moved before the solder was cool, so that was not going to be a strong joint. Alright, that'll be good. And this goes to ground. If I'm not using insulated wire to jump distances, I try to use either strong leads or thin leads like these resistors and double them up. That way there's something a little stronger, a little tougher, a little less likely to bend and create pesky bugs, pesky short circuits. I've built circuits where, after handling them a bunch, they only work if you bend them a certain way. so then I'll have to tweak, bend, stick my screwdriver with the power off and kind of bend all the leads apart. Make sure they're not close to touching. And that always works. I've never burnt up any chips or anything like that with a surprise short. I have burnt chips up by connecting power leads backwards. That's a bummer. And I've burnt chips up by using NE5532 op amps and not dealing with the inputs the right way. Try to stay away from NE5532s unless it's in a pure audio circuit that isn't doing anything kind of special.
Check out there, buddy.
Alright, so we got the potentiometer installed, this 1K resistor to ground installed, and the input jack. I gotta check in here.
Crossroads.
My turn. Vander Ark B.
Vander Ark A.
Cool.
Thanks, I got it.
Alright, I'm gonna need two 20K resistors. This circuit comes from Music from Outer Space, MFOS. Well, this is where I kind of got the schematic. And they use 15K resistors. but I'm running out of 15K resistors, so I went ahead and used 20K. You can use 15K. I'm sure you could use anything between, I don't know, maybe 10K and probably 47K. I don't know. All right, here's my NPN resistor, not pointing in. I like my little drawing because it seems so clear to me. This is the way the transistor stands, and so this is going to be the one with an arrow. This is going to be the other one, the one without an arrow. So this one goes to the 20K resistor, and then goes to the minus rail, the negative voltage rail. Keeping your leads short is always a good idea. And this goes to, since this is the NPN, it goes to the minus 12 volt rail. Very dexterous today. All right. Now let me grab my NPN. My bad, my PNP. My 2 and 3 906. If you're going to use a BC5 whatever, the pinout is flipped. So whatever transistor you're using, look up the pinouts. In the Roland TB303, the pinout is for the transistors in the diode ladder filter. It's like, here's the device, and here's pin 1, pin 2, and pin 3. And this is the base, and this is the collector, and this is the emitter. And that's bonkers. Why would the base be off to the side? But anyway, that's not what we're talking about. Ignore this. Why did I even draw it? I'm sorry. Foolish of me. Okay, so this little transistor has the guy with the arrow is the top one. So this is going to go to the 20K resistor, and it's going to connect to the positive rail. Let's see if I can be more dexterous with this wrapping. Yeah, that's better. Goes to the positive voltage rail right there. Fantastic. Another variation on this circuit. can simply duplicate this part of the circuit with the two transistors, the input resistor, the output resistor, and the op amp. I'm sorry, not the op amp. Forget that. Just that part of the circuit right there, and duplicate that like this. If you do, you can get a crazy complex waveform out of a very simple waveform. I think that 2 stages is plenty, maybe even too much. Wavefolders can get pretty nuts. Alright, the bases of the 2 transistors go straight together. And with these transistors and with most transistors, the middle leg is the base. So the middle leg goes to the middle leg. Middle leg to middle leg. See, not feeling very dexterous. I'm cutting the leads to make them short. As short as necessary. Alright. Let me solder these and then I will go do my bed check. Alright. When you're soldering transistor legs, transistor pins, be aware that sometimes they take a minute to take a really good, to get nice and wet from the solder. But that looks good. In all my circuits that have had mysterious failures, most of the mysterious failures are because transistor legs aren't, kind of came unconnected. Okay, be right back. So now we got the bases connected. Now it's time to connect the other 2. One of them's going to be a collector, one of them's going to be emitter. But those terms have never really made intuitive sense to me. I think the emitter is the one that connects to ground, and the collector is the one that connects to the low part of the circuit, the lower voltage, and the other one is connected to the higher. But I'm really not sure. If I only had some formal education. Alright, that looks nice. Since transistor legs are pretty strong anyway, they're not the flimsiest component lead. And since there's a double of them right there, that'll be nice and strong. The likelihood of that bending and touching another part of the circuit is very low. Alright, there we go. The bases of this transistor pair connect to the potentiometer. I'm going to use one of those 1K resistors. it has nice sturdy leads. Nice sturdy leads are sweet because they're strong, but they're kind of a pain because they transmit heat really fast, so they get really hot really quick. So if you're holding it, it'll burn you. If you choose to buy a bunch of stereo potentiometers or dual gang potentiometers, you can always get a stronger connection, mechanically stronger, by bending the pins together. I might use this potentiometer later in a different circuit, so I don't really want to bend the two middle pins together. This is just a temporary build-up, a prototype, if you will. Because I do want to have a voltage-controlled Lockhart wave folder. Alright, so the 1K resistor from the potentiometer goes to the bases. The bases are the middle pins. So we'll go like that. Other side, that part right there, goes through a 1K resistor to the inverting input of the op-amp. And back to a little skinny beige 1K resistor. You know what? I'm going to take this off the faceplate for now, so I can finish the rest of the circuit. Let's use this side of the op-amp. Here's the 1K resistor. In an inverting amplifier, the ground, or the positive, the non-inverting input, is connected to, well, usually to ground, but you can connect it to a different voltage. You can connect it to a potentiometer between positive and negative, and that will change the offset of the output waveform. If you connect it to ground, the offset of the output waveform, it won't be offset, it'll be centered around ground. So the gain for an inverting amplifier is set by the relationship between the input resistor and the feedback resistor. The input in this case, the gain is 100 because 100 divided by 1 is 100. If you have a 20K and a 40K resistor, the gain will be 2 because the feedback resistor divided by the input resistor is your total gain. Gain is figured in how much. If you have a gain of 2 and you input 1 volt, what comes out will be 2 volts. 2 is doubling the output voltage, 3, 4, 5, etc. Now if you're talking about decibels, I think it's 3 decibels per 1 gain, or maybe it's 6 decibels per 1 gain, I can't remember. Alright, now I'm going to terminate the other side, or I'm going to connect the inputs of this other half of the op amp. The way I'm going to do that is just by kind of squeezing them together on the points and putting a dab of solder on them. This is the output pin, and this is the inverting input pin. Because this here is the north end of the chip, the end of the chip with a little cutout. Alright, so my 1K input resistor is right there. Now I need a 100K feedback resistor. I will get my burrito of resistors, and I will carefully select. I will curate, shall we say, a resistor of the proper resistance. 100K. Perfect. Well, not perfect. I'm going to revisit that joint once I get the other end of the resistor nice and secure. Okay, now that was a little wobbly while it was cooling, so I will touch it with a nice bit of fresh solder and get it looking nice and shiny. That 1K resistor seems to want to bounce away a little bit, so I will hold it in place, heat it up, and let it cool. Perfecto. I have been neglecting to mark off components as I get them installed. So we got the input resistor. No, we don't. We don't have. Yes, we do. Here's the input resistor from the potentiometer to the rest of the circuit. Got that done. We got the NPN resistor, the PNP transistor. I said resistor. The two 20K resistors, the 1K resistor from the output of this little circuit, these two transistor pair, to the op amp, and the feedback resistor of the op amp. Now I just need a 680K resistor to the output. So we are basically done, you guys. Basically done. Before I put the little chunk of circuitry onto the faceplate, I'm going to connect power leads to this. It needs a positive 12, a negative 12, and a ground. Here's the kind of power cable I use. It's made of twisted pair category 5 network cable. I take it apart, take out the orange, the white, and the green. That's what I use. I'll be right back. back. I'm ready to turn these wires into power leads. In my synthesizer, the convention is green is negative, white is ground, and orange or brown is plus. It used to not be that. I used to have white be negative, blue be positive, and some other color like Christmas tree light wire be ground. Oh, and I built 4 Thomas Henry X4046 VCOs, full featured with all the bells and whistles. I built them all, plugged them in, and they all fried because I had the power connection backwards. I think I had positive to positive, negative to ground, and ground to negative. Okay, am I doing this right? Okay, there's the little divot in the north end of the chip, and that pin is plus. The pin to the opposite side of that is minus. Now, solid core category 5 network cable has, you know, for a circuit like this, it's got comparatively a good chunk of copper. Did I say monofilament? I guess I meant single strand. So, solid core, I think I said solid core, that's what I said. Solid core network cable transmits heat very well indeed. So when you're soldering with this stuff, it's going to burn your fingers. You can work quickly and minimize the burning of the fingers, like that, or you can just be like, oh, that hurts. Alright, that looks okay. Now, it's time. Okay, that does look okay, but I'm still going to need to connect this to the ground of the front panel. That is a step that I forget way too often. I didn't forget it this time. I'm going to do it now. I'm going to use some 40 wire, 40 conductor IDE cable, because this stuff is so easy to work with. I love it. And it's basically free if you know people, or you yourself are a hoarder and have a dozen old desktops, towers in your basement. Probably have access to hundreds of yards of this kind of wire. Multi-strand, nice and flexible. I will avoid, why not just do it to the same spot? There we go. That looks great. Now, the resistor from the potentiometer to the bases of the transistor pair. I'm making that solder joint nice and strong. Alright, let's look at what we've got. We have got a good looking little circuit. Nothing is likely to run into each other. I'm not very happy with this, because if this gets pulled on, it wiggles the whole circuit. The whole thing is going to flex. My solution in this case will be to rebuild this circuit with a VCA taking the place of this resistor, of this potentiometer. And I'll solidify everything, I'll tie it down there. If you're building it like this, I would recommend using another wire like this to connect the circuit to the wiper of the potentiometer, and then I would use some hot glue or something and mount this somewhere securely, and then I would connect the ground wire to something sturdy like the tab of one of the input jacks. That way if the power wire gets yanked on, you're just yanking against something that's mechanically very strong, something like right here. Alright, I'm going to get my synthesizer out, hook this thing up, power it on, and hopefully make some Batman waves. Okay, so I have the power wires connected together. Here's the circuit. It hasn't been bent or messed up or anything. So let's see if it explodes when I turn the power on. No explosions. That's good. Okay, now let's get a nice sine wave. This one sounds a little distorted. I don't know why that one... Well, anyway, this one sounds better. Alright. What we're going to do now is feed this nice sine wave through... Oh my gosh, I forgot to put the output to the pin. Okay, so what I forgot to do was I forgot to put the output of this op amp to the output of the jack. So I'm so embarrassed. So I got my 680K resistor, 680R resistor, and I'll be putting it from that output pin. Oh, by the way, I turned off my synthesizer so that way I'm not soldering on a live circuit. I mean, if you really want to live dangerously, you can solder on a live circuit. But it's dangerous. Just saying. Memorizing the pinout of a typical op amp can make circuit building a lot easier and more intuitive. Like, I know which pin is out, which pin is inverting in, and which pin is non-inverting in. That's a pretty ridiculously... That's a little better. There we go. Now I'll send my soldering iron back to where it needs to go. Out of the way. Hot. Don't need that kind of heat hanging around. Alright. Try again. Okay. Here's my sine wave. Plugging it into the input. And then putting a patch cable right there. That's the output. And then plugging it into the mixer. Ooh, there's a lot of noise. Maybe there's a lot of noise because it's a high gain circuit. You can hear that noise coming from the rest of my synth. The 100 gain circuit right there in this op amp, that's going to be picking up noise, especially since nothing in here is enclosed in any kind of shielded enclosure. Like, listen to this. It's not too bad. I thought it would be worse. Alright. The other thing to notice is that the output of this, the folded wave, has a much higher amplitude than just the plain old sine wave, which I will plug into the same input on my mixer. Plugging it in. See, that's as loud as it is. I'll turn up the mixer. Or the final amp. Okay. And then plugging it back into the folder. Turning this. Alright. Now I'm going to grab my oscilloscope and we can look at the waveforms. Yay! If I can make it happen.